How many numbers between 2000 and 5000 can be made from the digit 1, 2, 4, 5, 7, 8 if each digit is used only once? It means we cannot repeat the digit. If I've already used 2 one time, then I cannot repeat the digit again. Now let's see what happens. At one look, I know I am talking about 4-digit formation here. Okay, 4-digit formation. So what could possibly be the number here? They say 2000 to 5000. I can start with a 2. There is no 3, so I have to start with a 4. Another option is 4, and then until 5000, right? Until 5000, it means it's just 5000. You cannot be doing 5001, 5002, cannot. So of course 5 is deleted. I have 2 options for this. Okay, 1 out of the 2 needs to be placed over there. So you put your option over here, done. Let's say the first number that I actually put was a 2. Let me see how much I have left now. I have 1, 4, 5, 7 and 8. So for the second space, I have an option of 5 digit. I can put any one out of the 5. Am I right? So here you will have a 5. Let's say the second digit that I'm actually putting is, first I said I'm putting a 2, right? Maybe the second digit I'm actually putting is a 5. So you remove the 5 from the game. How much more left? You have 4 more. 4 more to be placed in the third space. Let's say you are actually putting the 8 over here. You remove. How much more option you have for your last space? 3 more. That's all. What is 2 times 5 times 4 times 3? Exactly 120. There are 120 ways where you can form number using 1, 2, 4, 5, 7, 8 without repeating the numbers. One option is this. Let's say the last one I'm putting a 1. What could be possibly the other? You try to list so that you can appreciate what you are doing. Maybe you can put a 2 here, and then a 4, and then a 7, and then a 5. Another option is, it also tells me that I can begin with a 4, right? I can put a 4 and then a 7, 1, a 2. So you have in total 120 ways of doing this. Let's go to another question now. An art exhibition, it has 7 paintings and it is all hung in a row along one wall. Find the number of possible arrangement for the 7 paintings. So if you're just hanging 7, and of course all the painting has to be different, right? They have to be unique. No one exhibits the same painting on the wall, right? So the answer is pretty simple, 7 factorial. Now they are saying, given that 3 paintings are by the same artist, out of the 7, 3 comes from the same artist. And then I have remaining 4, some other painters might have painted. Now we have to find the number of arrangement in which 3 paintings are hung side by side. Remember what I told you? They have to be together. In that case, what do? You group them. Painting 1, painting 2, painting 3. This is from the same painter. And then you have another 4 more, which can be hung in whatever order you like. Now what we're going to do? We're going to juggle all these items. How many space you have now? 5. So you do outside the group first. So 1, 2, 3, 4, 5. You juggle all of these. You're going to get 5 factorial. Times by, you go inside the group now. When you go inside the group, of course they are in a row. Look at the question. They are hung in a row. So you can also juggle them. What will you get? 3 factorial. Let's see what is 5 factorial times 3 factorial. That is 720. So if you don't understand, try to imagine how will 3 factorial look like. We know 3 factorial is equal to 6, right? But what is that 6? It's just P1, P2, P3, or P1, P3, P2. I can start with P2, P1, P3, P2, P3, P1. Like that. It's easy if you can see the listing behind it. What is the meaning of this 5 factorial? The grouped one is here. I'm having some other 4 paintings here, right? Okay, let's just put it as letter L. Okay, all the painting I'm labeling it is L. Maybe I put the first painting here. Then this is the grouped one from the same guy. And then L2, L3, L4. Maybe I want to hang L2, L3 and then all the 3 in same row. And then L4 and L1. So if you were to do, you're going to get how many? 120 options here, and each one of these, it's literally giving you a 6. That's why we are doing 120 times by 6. Now let's go to part B. In part B, what are they saying? Any one of these painting is hung at the beginning, okay, of the row, but neither of the other two is hung at the end of the row. Let's do listing and understand. Okay, let's say I'm doing painting 1. I hang this first. But I know the last space here, it cannot be painting 2 or painting 3. This is not allowed. If it is none from the same artist, then definitely the last space is taken by the remaining 4 painting. Am I right? Am I right? So how many options do you have now for the back space? 4. Very good. Because you have 4 from the different artists. So you have 4 options here. And how about the front? You can put a picture 1, a painting 1, or painting 2, or painting 3. You have 3 options. So you can put any one out of the 3. So we got a 3 here, we got a 4 here. Let's see what will happen in the middle. What will happen? By now you should have realized that, oh, you already used up 1 from here. So leftover is 2. You have also used up 1 from here for your last position, correct? So there is a leftover of 3. So these 5 here together, they can be placed in the middle. And their order, of course, needs to be juggled. 5 factorial. My final answer is giving me 1 4 4